And when there occurs a leak, the first question is coming, when was the last inspection and why we didn't catch this up? So it's just the first, the business of the inspection department. And also, as Dirk said, and combining with the Marcos thing, it's a culture. It's not the thing that should be the equipment integrity, but the system integrity is very important. When we come to we just encountered a fire and searching for a valve. It's a stainless steel special valve, something else. And we were searching in the warehouse. We just ordered from Spain. I was in Turkey. And we just bought business class seats for the valve. But after the day, we found it in the warehouse. The same valve. So it was the memories that I have, so it's the sharing moment.
So fun that everybody has that experience.
Yeah, exactly. So, and 20% is the optimistic approach I've done that project in. And just I would like to express my that I'm very pleased to be with you, all of you here. And in September 2024, we carried out the first edition of this summit in Istanbul, Turkey. And this event remains remarkably intense, so that it's been the 5th one here. So it's very great to be here with you all. Today we will discuss the parameters that will be the barrier about what we have in our facilities. And to do first, we will take a look at the scope of the inspections and why these inspections are coming from central to the integrity studies and evolved by time. We will continue with introducing the parameters. What are those parameters? And defining the barrier. We will establish the relationship between the barrier and the parameter. Preparations made prior to the scheduled maintenance in the industrial facilities are very vital for the effectiveness of the maintenances or the business actions carried out in the field. So mostly the importance, initially inspection scopes were coming from the time-based applications. It was the regulatory requirements, rules, or the prescriptions that have been written down on the papers and all the rules. Then it just evolved with the situational awareness began to emerge. So the technological things in the inspection methods increased and advancements occurred. So methods changed a lot. So then we found out that condition and possibilities are the main things in determining why we are making the inspections and determining the inspection scopes. Then afterwards, we just realized that risk is the everything that should be looking on the consequence and the probability. We can be discovering what's the risk on the equipment and where we should be spending our inspection and maintenance efforts. So it became damage mechanisms. We understand the damage mechanisms also. So, but with the dynamic thing in our plants, many dynamical changing situations in industrial plants we have. And why does the scope of the inspections based on, for example, the RBI studies remain the same that were performed through the instantaneous decisions? So we have the question that, well, is it enough for a dynamic inspection scope? Yeah, we all know that the basis of design of the plants can be defined as the design windows when we come to the parameters. And then the window that contains the parameters designed process is economically feasible or not, then it becomes the economical the process window result. And with those that contains the parameters affecting the integrity of the equipment, it becomes the integrity operating window. And all of the total, we just go through those ones. When we make them, we create the operating window then, where should be standing on. The combination all of these results making the operating window can be listed in two categories. The physical ones and the chemical ones. There are some examples. The chemical ones can be the fluid inside, acid concentration or something else, and the physical ones can be the wall thickness, corrosion allowance. So we can go with those ones. All physical and chemical areas have upper or lower limits. It's defined that when these limits, whether upper or lower, doesn't matter, violated, they are categorized according to their risks involved, resulting in three main categories, but we see four. I will explain that one. The critical ones are the ones that are immediate action. They need immediate interaction. So, for example, most of these, the best example for that one is the tube skin temperatures in the furnaces. As you know, because of the creep mechanism, it can just lower the operating life of the tube furnaces. That's we need immediate action to reduce that temperature down. And limits that are the best other terminology used for these critical ones are the operational safe operating limit or the safety critical limit. We can say that. And for the one level below the critical one is the standard limits, but it's divided also into the two categories, subcategories. It's called one medium high risk ones and medium risk ones. These are divided according to their intervention. For the medium high ones, alarms are triggered. And operators are expected to quickly go through the predetermined actions. So they will reduce the effects and consequences can be hindered. For the medium limit ones, the operators are expected to promptly notify the supervisors or the SMEs accordingly, and then carry out the instructions they are provided. Limits with the lowest risks are referred as the informational ones. These informational ones are the parameters that affect equipment or the facility in the long term. And we can, for some of these parameters, relevant SMEs are carrying out the studies according to those ones. Maybe with those parameters, some of those parameters, operators are not aware of that one also. So one of the most commonly used methods, I'm just coming to the subject of the barriers, how the parameter is connected with the barriers, but we should be defining the barrier. What is that? For the process safety studies, maybe you have seen several times this one, the bow tie analysis. And in the center we have the hazard and the major event, top event, let's say. And on the left-hand side we see the threats in the blue colors, and on the right-hand side we see the consequences. And that's in between the top event with the threats and the consequences, we have barriers. So these barriers are, if those are on the left-hand side, we say that that's the prevention zone. And on the right-hand side, it's the mitigation zone when it comes to that one. So what does it mean for the integrity of the equipment when it comes to in the top event, we can say that it's the LOPC, the loss of primary containment. And what can be the threat for the integrity point of view? Degradation of the material. If you degrade the material, then you will have the LOPC. But what's the barrier in between? Parameter is the integrity operating window that we have defined in the previous slides. So it becomes the safety critical element for us because it's just directly affecting the all top events. So we will make it more concrete with the sample case that's carried out. But before that one, you see that this is the extract from the API 571. It gives the generic information about the process units in the refineries. Even though it says refining industry in the name of the recommended practice, it gives lots of information for the whole industrial facilities. So we can have this much information for the damage mechanisms that we can encounter. And our sample case, which is occurred in a refinery, took place in the atomizer section. Here is that one. And it's a real case, and I was the responsible inspector during that time. And the question was raised, the same question was raised. It was a process safety incident, and tier 1, when we just make it on the related API 585 or something, 84 it should be. The incident occurred in a unit that was commissioned in 2010, and after its construction was completed. And prior to commissioning, RBI studies had been carried out, damage mechanisms and associated IOVs also determined. And all the limits are known. Till, what we have talked till now is just determined, and everybody knows about those ones. Physical limits are also in place, present in the system. We know the carbon steel material, they are all recorded in the BOMs, all the definitions, everything else is recorded. But after 9 months of operation, a leak occurred, just only 9 months. A pressure drop occurred in the separation drum that's in the system, separation drum. And operators take the field visit and seen that the exchanger shell is leaking. And it was the LPG. And due to its location in the upper part of the unit structure and prevailing wind, it was just to the sea, so it didn't ignite. It didn't make an explosion, so it was very important for that one. It was a lucky moment for the facility. But it's a tier 1, and tons of LPG just leaked from that equipment. So investigations after the incident revealed that 18 millimeters of shell deteriorated due to the hydrochloric acid corrosion. And calculations show that actual corrosion rate, you see that, 27 millimeters per year. And you can just realize even in 1 month, and the design was just 0.15 as the design value. So what's missing here? We have everything, RBI studies, limits, everything we have. They are all defined. It's a nice drawing. I make these ones. This is the Turkish word, flow. I make these studies. What was missing? There was no monitoring system for the parameters. So nobody is warned about the violation of these parameters. We have put the limits. But if the limits are violated, who will be informed? And in which manner they will be informed? Is it critical? Is it standard? Or what should be done after that one? If we see the high content of the iron, let's see, or chloride, what should be done? So there was no system in place. And we should be careful about what we are working on. And we can be safe with if we are conscious about what we are doing. And can you accept 300 millimeters of chloride under these circumstances, or above exceeding to I think it was 80%, 80 ppm weight iron content in the boot water. Here you just make the sample and you see that one. You cannot accept. But if you know that, you cannot accept. These IOV parameters are valid for the age-related mechanisms. We have been talking about the age-related mechanisms, but when we just come to the non-age-related mechanisms, it becomes non-age-related mechanisms, stress corrosion cracking, something like that. It changes a little bit, but we should be again aware of the parameter that we are having. So, we should be keeping the RBI studies, or not the RBI studies, all of our studies alive. Just giving the example on the RBI one. Reliability integrity studies should be especially we should be keeping them alive by defining the corrosion loops. These corrosion loops will be defined with the damage mechanisms that they have, and also determine the operating parameters and the frequency and the measurement frequency and the limits for those ones. And of course, at the continuation, we need to have the live monitoring system. Since we have in our sample case, everything was set, but there was no monitoring system. So we just encountered that problem. So 9 months brand new equipment just leaked. And afterwards, we should be reviewing a regular basis so that we can understand if the dynamics are changing or not, if it's still valid, what we have determined in our previous studies. Hopefully, I can convey how IOV is connected with a barrier, which should be defined as the safety critical parameter and prevent a high potential process safety incident. So thank you for all, and I welcome all questions and comments from you.